Hi, welcome. My name is Davide Valeriani, and here I'm presenting our recent research on brain-computer interfaces for optimal human-machine collaboration. We know that in group decision-making, BCIs could help to improve group decision-making performance in both human and human-machine teams. We also know that in some scenarios, in most of the settings actually, receiving advice from others could be beneficial for the decision-making performance, but in other settings could be also detrimental. So our question was whether we can develop BCIs to understand if a person is willing to take into advice from their brain activity, from their brain signals. So before the whole pandemic started, we designed a realistic decision-making experiment involving a pandemic scenario. The task here was showing, so we showed participant images of a fictionary geographic region. There were like two areas in this region labeled 1 and 2 with dots representing cases of an imaginary disease, and the color of the dot represented the severity of the case. And we showed this image for half a second to the participant, and then we asked them to decide whether region 1 or region 2 was most in danger. After this, we asked them to estimate their confidence in that decision, and then we showed them feedback representing the decision and confidence of an artificial agent in the same task. And then we gave the participant the opportunity to change their mind or to confirm their previous decision. We recorded neural data from 128 EEG electrodes across 14 participants, and we group epochs depending on whether the person changed or not his or her mind following a conflicting decision from the agent. And we label this as trust, when you change your mind because you trust the other agent more than you trust yourself, or distrust is if you trust you more than yourself more than the other agent. So what we found by averaging EEG data from trust and distrust trials across participants, we found the neural correlate of openness to advice between 150 and 350 milliseconds after receiving the feedback in the left parietal and occipital electrodes. Here, for example, you see the electrode P7, and the dots, the black dots on top show where the two curves are significantly different from each other. And on the right, you see the scalp map showing the distribution of these differences across the scalp. And that's when you localize these differences in the parietal and occipital regions. So to conclude, we showed in this research these neural correlates of openness to advice, where they are located and when in time they happen. And this could enable the development of new BCIs to understand if a person is willing to receive advice and then give them advice by another agent or from another human. And so developing BCIs for optimally collaborating machines that only give advice when this advice is needed and requested. Here are my contact information. Please do follow up for extra questions and discussion. Thank you.